Now this, we are going to have to remember something from a while back. You remember what's the shortest distance between a point and a line? Even more than that. It is a straight line, but what kind of straight line? Hang on one second. How does the straight line relate to the line that we're trying to find the distance to? Yes. So the shortest distance between this point and this line would be this segment that's perpendicular to the other one. Same thing here. Okay? The shortest distance between a point and a line is the perpendicular line from that point to the line. So what the theorem is saying, those two red chords can only be equal if these two white segments that I just drew are equal. The only way that chords are equal is if they are the same distance from the center. And this is one that you could use in a couple different ways. As long as you know that like these two segments are equal, well, the two red ones would have to be equal. So you can set up and solve the problem. Or the other way, if you know that the two chords are equal, the distances between them would also be equal. And then again, it's just a lot of setting up an algebra problem with your variables and solving. So that's how those work.
So like the two halves of those chords would be congruent to each other. So it's like, you know, the short half of the red lines would be congruent to the
right, because if you extended this out, it'd be a radius.
right.
So then it would fit that earlier one. So that's also true. So all four halves would equal each other as well. So your assignment on this one. A lot of odds again. 1 through 21 odds is the stuff from today. And then I did throw a little bit of review in there. We are getting close to the EOCs. We will have a little bit more here and there. Stuff that hopefully you remember pretty well. And we're actually going to work some of these out to begin with before we move on to the next one. So quickly get that written down. Books open to page 704. I think we'll do like the first 5 together, and then we'll look at our next section. Okay, directions for 1 and 3 state to do what, Lane?
Find the value of x.
So no plugging back in. We just got to figure out what the variable is. Look at number 1. What do you think about it? No thoughts at all? As long as you don't use slow.
Chords would be equal.
Yes. So what's x going to have to be? Think about some stuff from last time. What kind of relationship, though, is true about the measure of a central angle and its minor arc? Shall we? It would. And the reasoning is if you tie what I was kind of saying with what Tyler said, those two arcs have to be equal because the two chords are. Because the one chord has a central angle of 93 degrees, that's its measure, so the other one also is 93 degrees. So don't forget that. Central angles have the same measures as their minor arcs. Number 3. How are we going to set that one up?
5x is equal to 3x plus 6.
Why is that our setup? Why are they equal, though? Yeah, their arcs have the same measure, so the chords must be congruent. So solve that for x. What do you get?
3 for x equals 3.
Yep. 35. This one, we were told in circle P, JK is 10. We want the measure of JLK, which is an arc, is 34. We're going to find each measure and round to the nearest hundredth. So look for PQ, since that's what we're finding. Thoughts on how to set this up? We are going to use a right triangle. So I'm just going to redraw that. I'm going to have you do the same thing. Just draw what we're looking at. So in that case, this would be J, this is P, this is Q. This is what we want, so I'm going to put the variable there. I know that's a right angle. What's the length of JP? Where'd that come from? Yeah, we've already got one radius. PM is 6, so any other ones also have to be 6. How long is JQ? How do you know that? Yep. So now what? So how are we going to set it up in this case? Okay, that can work. As long as the 6 is on the side by itself. So 25 plus x squared equals 36. Subtract, so x squared equals 11. Take the square root of both sides. So x is, find that to the nearest hundredth this time. That's what it asked for. We didn't want just a radical. What is the square root of 11? The nearest hundredth.
3.3.
Yep. And just so we have an example one like this, go ahead and add 6 to this. I'll give you a point on your homework for it. So we haven't done one like this type yet. This is using that last rule. Go ahead and read number 6. Think about how you'd set it up. Tyler's thinking.
So we just put 9 equals 4x plus 1.
And why is that the correct setup?
Because they're both perpendicular.
And they're both 5 away from the center. So that's using that last one that said if they are the same distance from the center, they have to be congruent. So that's why that's okay to do. So solve that. What do you get for x? 2. Now you can kind of see on all these, there wasn't really a whole lot of work. Number 5 had the most, but it was still just the Pythagorean theorem. Just once you see how to get these set up, you can get through them pretty quick. So remember the rules. Yeah. So that is 10.3. We are going to go and look at 10.4.